And welcome back to the morning show. You know, TVs just keep getting thinner and sharper. The technology just keeps growing every day. And joining us to talk about more technology and how some of these small TVs and thin TVs works is our wise guy, Matt Sellon. Good morning, Matt.
Good morning, Rob. So here's a little laptop that I got about a year ago, and it's really thin. It's about a ½ an inch. The screen is just really thin, and you got to wonder how these things work. And last week we talked about how regular cathode ray tube TVs work, and they're, you know, big long electron beams. You have to steer them around and hit the screen and all that kind of stuff, right? And so they're thick. And so the key with those, though, we saw was that you hit the screen in individual little spots, and you end up with little tiny dots. And when you stand far enough back, you don't see that they're dots. It just looks like color to you. And so if you were to take a magnifying glass to a flat panel screen, or maybe your TV at home, your flat panel TV, you would see that they're just little dots too. And so the trick is, how do you turn little tiny dots individually off and on? And the way that these flat panel things work is in a way much simpler than your cathode ray TV, because there you have to steer beams around and things. With these, the computer that's inside just turns on and off each individual little tiny dot one at a time.
That makes it easy.
It makes it really simple. And so the question is, how do you actually do that? How do you get to one little spot and with small voltages make a light either get through there or not get through there? And the answer is polarizers.
Oh, polarizers.
Okay? Polarizers. It turns out that light has what's called a sort of a direction associated with it. Not only does it go in one direction, which of course, like when you shine a flashlight, the light waves have an electric field that vibrate either basically up or down or left and right or someplace in between. And you can select that with just by making a sheet of plastic or glass that has long skinny molecules oriented one way or the other. You can select light that's either vibrating up or down or left and right. Let's just say that. Okay. So what I have right here, right now, in this little box, is just, there's a fluorescent light in behind this thing, then there's a polarizer in front that's selecting light that's basically where the electric field is wiggling up and down. If I take a second polarizer and I put it in the same orientation, so this one lets through light that's wiggling up and down, all the light gets through.
Right.
Because, well, the first one selects the same ones as the second one. If I rotate this so that the second polarizer would only let light through that's wiggling left and right, then you don't see any light, because the first one gets basically half of them and the second one gets the other half, okay? Now, if I take this glass of corn syrup and I stick it in between, what do you see? You see light getting through all of a sudden. And what's happening here is that even though without anything in between, no light would get through these cross polarizers, this corn syrup has the property that as light enters it, it can rotate the polarization of the light. So if light enters the corn syrup wiggling up and down, it comes out wiggling left and right, and so it gets through the second polarizer. And so the trick is, so for each pixel on your laptop screen or whatever it is, you'd like to have an arrangement like this, but you'd like to be able to switch the corn syrup in and out, you know, in a fraction of a millisecond without having to stick some gooey, messy crap in there.
You don't want corn syrup all over the place, right?
Right. And so the key is something called liquid crystals, because liquid crystals are molecules whose orientation you can control with an electric field, and also that have the property that if you get enough of them in a row, they can rotate polarization.
Very nice.
Right, and so what you have then, and so basically what we'll do when we come back is we'll describe exactly how liquid crystal displays work, or how these things work. But what I can show you before is a lot of household things have the property that you can rotate polarization. So just some cellophane, if I stick it in here, okay, looks kind of colorful and pretty.
Ooh,
see that? Pretty. Okay. Common things like plastic forks, right? Sound effects are very important when you do this.
Yes, they are.
Yes,
here,
okay.
I'll do them for you. There, okay.
Okay.
All right. Well, we're just about out of time for this segment. You're going to be back at 7:25.
Right.
Matt Sellon, the Wise Guy. And if you have any questions for the Wise Guy, send them into the morning show at wcia.com. Don't forget the Wise Guy's website online, wiseguy.net. Well, thank you for joining us. And I said you'll be back at 7:25. Now a check for weather from Robert Reese.